Report number 3 is presented by Kaylee Childs, Nick Zyma, and Elise Fournier. In this experiment, we looked at a mantis shrimp versus a professional boxer, and we want to know who does more work. The goal of this experiment was to consider the biological phenomena of the punch of the mantis shrimp, found in the warm waters of the Indian and Pacific Oceans. They have an extremely quick punch that they use to dismantle their prey. This punch can reach up to a maximum acceleration of 120,000 meters per second squared and can also punch with a force almost 2,500 times its body weight. The shrimp uses its powerful claws to spear, stun, and dismember their prey. In this experiment, we wanted to see just how powerful a mantis shrimp punch is in comparison to boxing legend Floyd Mayweather.
We are using video models to investigate the total work that each punch packs. Some other models that can be used are the free body diagram and the energy pie chart. For the free body diagram, there is only a resistive force acting upon the shrimp of the water. Somehow, the shrimp overcomes this force and creates a small explosion in the water, but that is at its fastest punch. We will be comparing 2 average claw punches to 2 average punches done by Floyd Mayweather. Another model used is the energy pie charts. These show how kinetic energy changes through the progression of the punch. At the beginning of the punch, kinetic energy is at its smallest, and as the punch progresses, it gets larger. The same exact models can be used for the boxer, except the punch is happening in air instead of water. Still, in both, there is some resistive force from either the air or the water. The work energy theorem is used to describe the interactions between the punch and their possible target. The amount of work done by each punch can be measured as a change of kinetic energy as the punch progresses. The work energy theorem is work equals change in kinetic energy, which equals 1/2 times mass times the change in velocity squared. We can measure terminal velocity from the graphs of position versus time from tracker. We can then use terminal velocity to calculate the change in kinetic energy. This value then equals work. So, who packs the bigger punch?
Seeing the force and kinetic energy of each punch allows us to compare the work being done by each organism, both human and shrimp. In order to get these values, YouTube videos were found for both the mantis shrimp and Floyd Mayweather. Then these videos were converted and put into the program Tracker, where they were analyzed to get data for position versus time graphs. Then the graphs were obtained, and from there, the velocities of the punches were determined through interpretation of the graphs while also comparing them to literature values. From there, the amount of work done could be calculated through the work energy theorem. It was predicted that the mantis shrimp would generate more kinetic energy and do more work than Floyd Mayweather.
Slightly slower frame rate of 2000.
Oh, that looks so awesome. You just can't see that with the naked eye.
Ring rust. Round by round, it became clear the smaller Marquez could not deal with the speed and power of Mayweather's punches.
First, we need to calculate the terminal velocity of the punches. For the mantis shrimp, the position of the end of the claw to the beginning of the retraction of the punch was measured using Tracker. For Floyd Mayweather, the same was done with the boxing glove. Both the mantis shrimp's punch and Floyd Mayweather's punch are described by these graphs, comparing change in distance over time. The linear slope of the graphs determine the average velocity of the punch. In order to compare the work done by Floyd Mayweather and the mantis shrimp, we need to use the equation work equals 1/2 mass times velocity squared. Plugging in the velocity values found in the above graphs and the masses of their boxing gloves and claws respectively, we find that Floyd does a greater amount of work than the shrimp. This is due to Floyd's gloves being much more massive than the mantis shrimp's punching appendages. Looking at the calculations, terminal velocity was used in the equation for kinetic energy. The kinetic energy for the mantis shrimp was 0.1498 joules. The kinetic energy for Floyd Mayweather was 108.73 joules. By the work energy theorem, this kinetic energy is proportional and equal to the amount of work done. In conclusion, the organism that does more work is Floyd Mayweather. This is because those boxing gloves are so much more massive than the mantis shrimp's claws. Possible sources of error in this experiment included there not being enough frames of video to accurately track the position of the mantis shrimp's claw. Another source of error could be the resistance of air in comparisons to the resistance in water. It would be interesting to see how Floyd Mayweather's punch would measure up to the mantis shrimps if they were both punching in water. Thanks for watching.